Hello everyone, my name is David Martinez and I'll be representing Catherine Wilkinson's Neurophysiology Laboratory at San Jose State University. It's a pleasure to be here for you guys and to introduce a topic that is not widely known, specifically for those who aren't studying science, but it's a very important sense in everyday life because it involves coordinated movement and is responsible for additional balance that allows your body to move so um, coordinatedly. Now, this sense of body positioning in space, formerly known as proprioception, is what our lab studies. And it's very important for everyday movement because it is essentially being able to know where every limb is in your body thanks to the information that is perceived by a very special unit within the muscle known as the muscle spindle. And this picks up information anywhere from the kind of degree of tilt that your muscle is being stretched in, to how strong the contraction is, and for how long and continuously you are doing that kind of stimulus. Um, all this information, even if they specifically wrote it down and gave it to you, you may not know what to do with it, but your brain does. And thanks to your brain, you're able to know where your body and limbs are at any given time throughout the day, thanks to these kinds of information and signals. Now, for those of you who don't know much about neuroscience and the nervous system and muscles, I'll explain it simply. Neurons have a long end known as the axon, and at the very end of this axon is the axon terminal, which releases sensory information and more specifically chemical neurotransmitters or hormones, and which once these are spilled out and perceived and picked up by the muscle fiber, it responds in a different way. Whether it can be an increase in movement or a decrease in movement, that depends on what is being communicated. Now, what we study is the essential role of glutamate, which we know from previous studies that an increase of exogenous glutamate, which is released from an outside source, not just within the body, from an outside source, would increase the receptiveness of the muscle spindle firing frequencies, so their responsiveness to stretch. But importantly to know is that more importantly, glutamate is not freely available within the body at any amount, in whatever kind of amounts. It needs to be controlled, such as anything in the body. So they're packaged in little tiny vesicles, circular vesicles, and these have an opening by a stretch-sensitive receptor known as VGLUT, which is the vesicular glutamate transporting vesicle unit. And this unit is responsible for allowing the release of glutamate into that muscle spindle and allowing for continuous stimulation when you're having stretch for a prolonged period of time will allow you to continuously be responsive. Now, most importantly, we want to know what would happen, and in our studies we use mice, but we would want to know what happens if you knock out one copy of the VGLUT gene.